Okay, looking at this one, what we'll note is that when the bases are the same, in other words, base E, base E, when the bases are the same, you add the exponents. So in other words, we're going to get e to the fourth raised to, one more time. You're going to get e raised to the 4 plus 11. In other words, e to the 15th. Okay, for this next one, I'm going to you could either break this up into two pieces. So you could break it up into 20 over 10 times e to the third divided by e to the sixth, or you can just kind of think of it that way. So I think that's what I'm going to do. I'm going to think of this as one piece, and I'm going to simplify it. And then I'm going to think of this as the second piece, and then I'm going to simplify it. Okay, just so I can keep this one fraction. So let's see here. For the 20 over 10, I think you guys would agree, 10 divides both the top and the bottom, so it's going to be 2 over 1 or 2. And then for the pink part, for e to the third divided by e to the sixth, the rule is if the bases are the same, you subtract exponents. So you'd get e to the negative 3. Okay, I'm just putting that 1 in the denominator just so I have some sort of denominator. From there, we would simplify. So reminder, when you have a negative exponent, that means reciprocal. So I'm going to make that exponent positive by bringing that term to the denominator. Okay. For this one, we have a power to a power. Reminder, we have everything inside the parentheses is being raised to a power. So I'm just going to do this, I'll just kind of indicate this in red. So we have this negative 3, which is being raised to a power of 1. And of course, we have that e term that's being raised to a negative 5x. So in this case, reminder what we do. What we're going to do in this case is we are going to take the power on the outside and we're going to multiply it to each of the powers on the inside. That's our power to our power rule. So in this case, I'm going to get negative 3, and then I'm going to multiply the exponent, so 1 times 2 is 2. And then I'm going to get e to the negative 5x, and I'm going to multiply it to that power. So in other words, when I'm finished, I'm going to get 9 e to the negative 10x. Again, what was done here was I took the power on the outside and I multiplied it to each of the powers on the inside. Okay? So for this one, we're supposed to determine whether we have exponential growth or decay, and then graph. So let's see what we can do here. Reminder that we have exponential growth when a is positive, so when this is positive, and when what I'm looking for here, and when the exponent itself is positive. So what I mean by that is the number in front of x is a positive number. So in this case, just to be clear, the number in front of the x is 1, so we have exponential growth. But on the other hand, if the number in front of the exponent had been -1, we'd have exponential decay. Okay? So let's go and graph this. I am going to need to grab a graph. Let's go and do that. So for this one, basically it just comes down to the fact that you'll be making a table. There isn't a lot more to it than that. For your table, let me see, I'm trying to figure out where I can fit this in. I'm going to move this graph over just a little bit. Okay, so for the table, I'm going to have something like this. So it's going to be x, y, and notice it's 1/3 times e to the x. That's a vertical shrink in this case. So I'm going to be, because it's vertical, you multiply it to y. So for the numbers, I think I'm going to use -1, 0, 1, and 2. So let's see what we got here. So normally when I get this, when I plug in my values, I'm going to get e to the -1, which is, I have to figure out where the e button, there it is. I was trying to figure out where the e button was on my calculator. So e to the -1. I'm also trying to figure out where the negative button is on my calculator. All right, oh, there it is, -1. Sorry about that. So I'm just going to round to the nearest, hundredth just so you guys can check your accuracy versus mine. But obviously, I'm not going to graph to that accuracy. So I get 3.7 when it's e to the 0 is just 1. E to the 1 is just e, which is about 2.7. And then e squared is, I am super slow on that, it's about 7.38. Now, reminder what I'm going to do. I'm going to take the column that I just made, so this column, and I'm going to multiply all those values by 1/3 to find that vertical stretch. So 0.37 divided by 3, same thing as multiplying by 1/3, is a very small number, 0.12. 1 times 1/3 is 1/3. 2.7 times 1/3 is 0.9. And then 7.38 times 1/3 is 2.46. So when we go to graph this, I'm going to make my graph, I'm just going to make my graph look like this. I think to make this easier for me, I'm going to make the y's go by 2's, because you can see my biggest number on the y's is just 2.46. So this will make the graphing a little bit easier. So let's see what we got here. I'm going to graph this in purple. So I'm going to start with the point 1 and 0.9. So 1 and 0.9, which is about here. Then I'm going to, I'm going to start with the point 0, 1/3. Let's do that. That's much better. 0, 1/3. Then I'm going to do the 1, 1.9, and then 2, just a correction. I think I said 1 and 1.9. It's 1 and 0.9. So now I'm going to do the 0.2 and about 2.5. So that's about here. Then I'm going to do the point -1.12, which is like maybe here. So the things that I'm looking for as you're going through, make sure that the graph hugs the x-axis but doesn't touch or cross it. And just be accurate on like this point. You know, I mean, try to be accurate on your points, but especially things like that y-intercept and stuff. Really focus on that. Okay? Let's move on to the next. Okay, so in this case, we're talking about exponential growth or decay. Notice how the number in front of x is negative, so we're going to exponential decay. Also, just a quick note, if you're not sure, so you're on a test and you're asked to do, like we did in number 4, you're asked to determine if it's exponential growth or decay, and you're not sure, you don't remember the rule, you can always look at your graph when you're finished it. Notice as I move from left to right, the graph is moving away, right? It's moving away from the x-axis. Because it's moving away from the x-axis, we have exponential growth. What you'll notice on the next one that we're going to do, the next one's going to do something like this, where it's getting closer and closer to the x-axis as I move from left to right. That's exponential decay. So this one, again, because the number in front of x is -1, we're going to have exponential decay. So let's go and make our table. So notice again, we have a stretch by 6, and it's a vertical stretch. So it's going to be 6 times y. I'm going to use the first two, I'm going to use most of the first two things that I did in my previous one. So I'm looking at my previous table. I'm looking at this, and I'm just going to use those 2 columns because they're pretty good. Except I think I'm going to start from -2. So I'm going to go -2, -1, 0, 1. And that's as far as I'm going to go. Maybe I'll do 2 also. So let's get in some numbers that we have here. So be careful. Remember, when you're plugging in your numbers, so for example, when I plug in -2 into this, right, it's -2 or +2. So in other words, we're going to get 7.38. That's again without the stretch. When I plug in -1, right, it's going to become -1 or +1. So it's either 1, which is 2.7. When I plug in 0, that's nice and easy. That's 1. When I plug in 1, that's going to be it's going to end up being e to the -1, which is 0.37. And then when I plug in 2, I'm going to need to do the math on that because that's e to the -2, which is small. 1 point, nope, excuse me. It's 0. Let's say 14. So now I'm going to take all those numbers and multiply them by 6. So 7.38 times 6 is really large. That looks like it's 44 point, let's say. It doesn't matter. I think you guys would agree it's just too big. 2.7 times 6 is 16.2. That's pretty large too. 1 times 6 is 6.37 times 6 is, what is that, 2.22, and 0.14 times 6 is 0.84. So for this one, I am going to go by 2's this time for the y values, just to give myself a little bit more room. So in other words, for 8, 12, 16, while the x's are still going to go by ones. Okay, so let's see. I have at 0, I have the point 6, which is right here. So I have the point 0.06. 1 is the point 2.2, which is maybe pretty much right there. I don't know why I changed colors. Let's see, 2 is 0.84, maybe here. I may be off on that estimate. Let's see, -1 is 16.2, so kind of here. So notice on this one, again, hug, but don't touch that horizontal asymptote. But notice it's exponential decay because as we go from left to right, the graph is getting closer and closer, to the x-axis, but not touching it like I did there. Okay, I'm going to stop there for now.